Hello and welcome to my new video. Today we will be speaking about climate models. And to keep the video short, to make it not too long, I will speak only about how climate models are working. So I will not speak about how reliable or unreliable climate models are, what they are predicting, or what the differences are between models for climate and models for weather. I will only speak about how climate models are being built, how they are working. Okay, enjoy and have fun. Let us start with a very schematic landscape and the letter T. T stands for temperature, and temperature is, of course, a very important factor in climate models or weather models or anything when we talk about weather. So, how is temperature, in this case above the oceans? Yeah, how does it, where does it come from? Very clear answer. The sun is the most important factor, of course. Solar radiation is hitting the oceans and is partially absorbed by the oceans. Part of the radiation is also reflected, but a good part is absorbed, and the oceans are heating up this way. And because they are warm, then they will emit infrared radiation, which is also emitted. So we could now talk about the further fate of this infrared radiation. This is quite important, actually. It's partially absorbed by greenhouse gases like carbon dioxide or water vapor, and then reflected again back to Earth. But I don't want this graphic to become too crowded, so I will skip this and will rather have a look at other areas like this ice sheet, for example. So when solar radiation is hitting a surface of ice, a much larger part of it is reflected when compared to open water. So here the ice will not heat up as strongly as the ocean will heat up, and a good part of this radiation is reflected. This is called albedo, by the way, and we will come back to this albedo later. Another surface where solar radiation is strongly reflected are clouds. So the surfaces of clouds, they reflect solar radiation quite strongly. They have a strong albedo as well. And so cloud cover is also reducing the amount of solar radiation which is reaching the ground and leading to increases in temperature. Warming up of the oceans also means that the air masses directly above the oceans will warm up as well. And when they warm up, they will expand. So they will become less dense and therefore they will rise. So they will go up. In addition to just going up, they also will transport water because when the surface of the oceans is warm, then water will evaporate at the surface and there will be water vapor. And this water vapor will be transported along with the rising air masses, so it will go up as well. And during going up, when the water vapor is going up, it will cool down, and after cooling below a certain point, water will condense again and will form small water droplets. And these small water droplets are what we are seeing then as clouds. Finally, these small water droplets in the clouds will condense even more to larger droplets or to ice particles and will fall down as rain, as precipitation. And this is then closing this little local water cycle we have defined here, and which is driven, of course, by solar radiation. So now we have spoken about movement of air masses, about wind, if you want. And these arrows down in the oceans are meant also to add that, of course, there are also movement of ocean masses, of water masses, so ocean currents, which are driven by heat or by differences in density. I don't want to go into too much detail here. I just want to indicate that, yeah, water masses are moving as well as air masses. So what we have done so far and what you can still see in the background is also a model. It's a model for some weather events over the ocean. So how the air above the oceans is warming up, how its clouds are forming, above the oceans, and how rain is falling from these clouds. These are very simple weather events, and it's a very simple model. There are many details are missing, which should be there. And in addition, there are also many other events which we should model if we really want to do a nice weather model or a nice climate model. Um, in the second part of this video, I will speak about things which have to fundamentally change when we really want to build up a climate model. What are the differences then between climate models and the things which we have collected here? Besides the fact, of course, that there has to be many more connections which we have to take a look at if we really want to speak about climate models or weather models. But apart of that, there are three main differences I want to show you here, which are important to understand climate. The first thing is that you have to feed everything into a computer. So you cannot just tell it by words or by using arrows, as I've done here, but you have to use mathematical formulas. And the example I gave you here is the barometric formula. This describes how the air pressure is decreasing with increasing height above the ground. And I don't want to go into too much detail about this formula. It's just an example how you really have to state the connections which I've talked about so far. That's not actually a real problem because scientists have researched about all these connections very long time, and most of the formulas we need for climate models are well known. Another difference is when you want to make a climate model is that you have to use numbers for as many things as possible because you want to have numbers as a result as well. So you want to know how much temperature will increase in a given time or how much wind speed will increase or decrease in a given time. And in order to be able to, for the program to give you such numbers, you have to start with numbers as well. So here's example, the values for the albedo of ice and of snow. And you see that the albedo of ice is somewhat smaller, and the albedo of snow, it can cover a large range. So actually, it's difficult to really tell precise numbers. But actually, this is not a very big problem as well, because nowadays we have satellites which are circling our globe and which can measure all these things which we have to feed into climate models. So they can measure the albedo of ice on every location, and so it's possible to feed these numbers or to get these numbers which we have to feed into climate models. Another difference is that it's not sufficient to simply look at these connections on a global scale. You have to look at local scales because conditions are very different on different parts of our planets. So different parts will receive different amount of sunlight depending on the season, whether it's winter or summer. And this means that in a climate model, we have to work many different cells for each part of this planet. And then calculate the transfer between these cells. So how much air is transported by wind from one cell to another, and how much ocean water is transported by ocean currents. And so the cells first have to be calculated separately, and then they have to be combined, and then the outcome is something like a climate. This was all I wanted to tell you about climate models. If you want to know more about this topic, have a look at the sources I'm writing in the comment section to this video. In addition, there are also really excellent videos available on YouTube about climate models. This is part of my own contribution here. And I will follow up this topic by speaking about certainty or uncertainties in climate models, about what climate models are actually predicting, and about differences between climate model and weather models. Next video will be a completely different topic. However, I still have to decide which topic, but we will see next time. So long.